So I want to talk to you about how we make our architectures just as able to respond to change as our systems. And we've actually gotten pretty good at this thing called requirements change. We've got this whole Agile manifesto and this whole software development lifecycle, which is focused on thinking about how do we make it easy to change the requirements of our system. But what about the ecosystem? Dave had a wonderful thing on his slide this morning. JavaScript frameworks are changing all the time. You know, when I started in this business, architecture actually meant how you designed the chip. Nobody talked about architecture in any other sense because it was bloody simple. Now, there's all kinds of things in the stack. And all of those things are fundamentally changing on a regular basis. And even if you don't want to adopt a particular change, like say Docker at a given point in time, you still need to think about your architecture in a different way just because this new technology is now part of our ecosystem. Now, many times people have accused me of being anti-architecture and anti-architect, and I am not. I will admit that there are some enterprise architects out there that I don't think do a very good job. But that doesn't mean their role isn't important. And a big part of their role is to protect the asset value of the IT estate over the long term. And they used to do this with long-term planning. And you would have these wonderful diagrams that are, multiple meters long on a wall that represented their 10-year roadmap for technology. We can't do that anymore. When Neil and I give this talk together, he will very often make a joke. I will bet you 100 of whatever your currency is that you can't tell me what JavaScript framework you're going to be using in a year because it hasn't been invented yet. So how do I do long-term planning? How do I do a good job as an architect when I have no idea how the landscape is going to change? And it used to be you had a pretty good idea many months in advance about these major changes, but we don't have that anymore. And so what we need to do is we need to start thinking about an evolutionary architecture. Now, when I first started talking about evolutionary architecture, people would come up to me, stand at the bottom of the stage at the end and whisper, "Don't you think you're being professionally irresponsible? You can't evolve an architecture. It's the rock. It's the foundation." People were mortally offended at the concept of an evolutionary architecture. Now, when they come up and whisper something, it's, "I know I need to do, but I have no idea how." And we're going to get into many of the hows today. But there are a couple of things that I want to talk about with respect to the name. And the first has to do with adaptable. Many people have said, why don't you call this an adaptable architecture? Well, most times when you think about adaptable, you think about an adapter. And if you're going to build an adapter, you have a pretty good idea, or you think you do, of what kind of things you have to adapt to. And that's the fundamental flaw, is we have no idea where these changes are going to come from. We can't predict them. But let's say you try. You build this adapter framework for this particular kind of change that you're expecting. And you have more lines of code, which means you have more bugs, and it's harder to understand. And then the real change comes along, and of course, it's not what you were expecting. And so now, it's probably harder to respond to the change that actually happened because you've done all of this work building all of this stuff that you don't need. Now, when Neil first started talking about this, I listened to his talk, and he called it an emergent architecture. And he and I had a very robust discussion on why that was a really bad name. I am perfectly comfortable with the concept of emergent design because bad code is bad code. whether it's a retail application, whether it's finance, whether it's health, whether it's a sandwich ordering system, doesn't matter. Bad code is bad code, good code is good code. And yes, it varies from language paradigm to language paradigm, but you and I will broadly agree what good code looks like. There is no such thing as a good architecture. Not one true good architecture, because problems are different. One of the systems I worked on early for Thoughtworks was a trading system. And you guys hear trading systems and you think low latency, high throughput, performance is critical. This organization, in their wildest dreams, never thought they would do more than 100 transactions a day. Not a second, not an hour, a day. They didn't care about low latency throughput. They cared about never, ever losing a message. So you can't say all systems need to have this level. Dave referenced a fitness function earlier, and you're going to see that appear a lot. Because what we want to do is we want to decide, one of our very early architectural decisions, what are the architectural characteristics that really matter. And we can use ideas from evolutionary computation to help then guide our architectural decision making. So that's how we landed on the name evolutionary architecture. Now, what about the definition? An evolutionary architecture supports guided incremental change across multiple dimensions. And just like Dave's definition, there are lots of important words in here too. The first one is guided. This is probably the single most important word here, because what we are going to do is we are going to guide the changes that we make and the decisions that we make in our architecture on the basis of those architectural characteristics that we care about. And we are going to fold those things into something called a fitness function. Now, in evolutionary computation, you have a definition of good. And you use various methods to come up with new answers until you get something that looks good. So it characterizes how close your solution is to what you're looking for. So we've co-opted this idea for architectural fitness functions, which capture how well your architecture, the various aspects of your architecture, reflect your desired architectural characteristics. Now, the single most important thing about a fitness function is you and I will never disagree on whether or not a system passes. So one of my personal favorite requirements from many central architecture groups, the code must be maintainable. What does that mean? We could argue about that. We can disagree on how maintainable a particular piece of code is. But we won't disagree on what the cyclomatic complexity is. We won't disagree around whether or not it respects the naming standards or the modular decomposition. All of those things are concrete. We would like them also all to be automated, but that's not a requirement. The only requirement is you and I have to be able to agree on whether or not a system passes, because that way we know where we stand. So we've co-opted this idea, but this is actually not that new. We're just using this one term to unify lots of different things that have been the scope of architectural governance in the past. If you've ever put a linter in, if you've ever put a cyclomatic complexity check in, you've used a fitness function. If you've ever put in an alert on a running system to say if the CPU utilization goes above a certain threshold, put out an alert. That's a fitness function, a different kind of fitness function. This is some examples of a fitness function. My personal favorite is the simian army. This is a dynamic, holistic fitness function that monitors various aspects of the Netflix estate. And an important part of this, and we're going to return to this a bit later, the important part of this is as soon as you put something into the simian army, no one ever has to worry about it from a governance perspective, because it's simply not going to be able to survive in the Netflix environment if one of the monkeys doesn't like it. Some of these are static. They'll be in a build. Some of them are dynamic. They're monitored, running. Some of them are very isolated on one particular characteristic. Some actually look at the balance between characteristics, which is important because these characteristics, we often have to decide how we're going to trade these off. Of course, the architect's favorite word is trade-off, because we can't optimize, we cannot maximize everything. Incremental change is the next important word or phrase. And there are two aspects to incremental change. One is, how do you actually change the functionality? This might be something like feature toggles or systems to set up to allow you to do A/B testing, but there's going to be something that you do to actually change the application incrementally. And then there's the operation side. How do you actually get this thing into production? An important characteristic of an evolutionary architecture is thinking about this: what is the path to production? How do I operationalize this evolutionary change? And going back to that, don't you think you're being professionally irresponsible comment, there are many things that we want to try to do in an evolutionary architecture, but a strong enabler for it is continuous delivery. And Dave talked about this a little bit. You want to be able to understand that the experiment that you're running, you have control of everything outside that context. The rigor and the discipline of continuous delivery provides that for you. And we're going to be using things like deployment pipelines as our operational mechanism for getting these things into production. And now, multiple dimensions. This is a poll from Wikipedia from a few years ago about just some of the ilities that we might care about. And if you look through this list, you'll understand there is no way that you could ever maximize everything on this list, because many of them are mutually exclusive. You cannot both maximize performance and maximize encryption, because encryption burns cycles. So you have to decide how much encryption is sufficient for my security needs, and how might I achieve that to get the performance that I want. Now, we're adding one ility to this list, and this is one place that I will respectfully disagree with Dave from this morning, because I don't think evolvability is an essential characteristic 100% of the time. Now, those that know me, I'm very skeptical about the words always and never anyway. But I was at a talk once. I had the thrill of going after somebody who ended their talk with a dancing robot. That was a hard act to follow. But he was talking about a particular analysis that had been run on a data set that was sent back from outer space, somewhere out there. Data set was only going to come once. The talk was actually about how they took advantage of the cloud as opposed to having to build a massive data center for this one data set. And the total bill was about $25. But what I took away from that is, in his particular case, he probably had other things to worry about than evolvability. Another example, we were working with someone who was doing fundamental research. And we were, in true Thoughtworks fashion, trying to get him to do TDD and test harnesses and all of this stuff. And he said, no, I'm not going to do that yet, because I'm sure I'm going to throw this away at least 2 more times. Why would I bother? Let me fiddle. Let's have enough structure that at least we know the code works. But let me throw it away. And then he said, okay, now I think I've got it. Now we're going to bring in this rigor. Evolvability is just like all of these other abilities. Maybe you need it, maybe you don't. If you are in an enterprise, if you are in a dynamic business environment, it's most likely something you're going to want to prioritize. But it's worth having the discussion, just like it's worth having the discussion of everything else on this list. Okay, so what are some of the principles that underlie what we're trying to do in evolutionary architecture? And the first thing is how and when we make decisions. One of the Agile principles, which we like to apply to architecture, is take decisions at the last responsible moment, because you have the most information. But how do you decide when that moment is? And a big determination of that are, what are the architectural characteristics that you've determined are critical for the success of your system, and how does this decision play into those architectural characteristics? Now, it's still not a cut and dry. I can't give you a nice algorithm to tell you Tuesday, January 14th of 2023 is going to be the last responsible moment. It's not like that. But you want to delay your decisions as long as possible so you have the most information. Now, maybe because you've got a procurement system that means you can't buy any software in anything less than 6 months, you might have to make a decision earlier than you would want. And then you might want to think about maybe building some kind of protection around it. But you start with your determination of what constitutes good for your system. We spent a whole lot of time on that trading system looking at the communication infrastructure and how we kept track of messages. Those were our critical decision points. The next is, if you've decided evolvability is important, you have to think about it both from the perspective of architecture and development. And I'll start with the development side first. You cannot change a system you do not understand. And so all of those principles that Dave talked about earlier are part of how do you make a system easier to understand. Because if you can't read it, if you can't understand it, you can't change it. And so this is where software quality in particular comes into play. If you've got a big ball of mud, if you've got a steaming pile of really ugly code, you're not going to be able to change it because you're not going to be able to understand it. But when we talk about architecting for evolvability, conceptually, this is in part thinking, where do I draw the boxes? Where do I draw the lines between the various parts of my system? And one of the things that we've learned from domain-driven design is the closer that our system understanding and our system Lego blocks that we want to move around correspond to how the organization thinks about how they do business, the more likely it's going to be easier to move those pieces around to implement a new piece of technology. Personally, I believe one of the reasons SOA went so horribly wrong is their boundaries were systems. Okay, I'm going to draw a service boundary around PeopleSoft, not customers or products or accounts or supply chains or any of those things that actually matter in how we deliver services and products to our customers, whether they be internal or external. You also want to think about this from the perspective, once again, of how these components interact with each other. If you've got component business logic on the path from component 1 to component 2, and now you want to insert something in the middle or you want to move the connection, you've got to change the pipe. Architecting for evolvability also focuses on smart endpoints, dumb pipes, because it's a whole lot easier to move a pipe that doesn't do anything except let stuff flow than it is to move a pipe that has all kinds of assumptions about who's on either end of that pipe. Postel's law. Simply stated, be very generous in what you receive. Asterisk, still protect yourself against hacking. If all you care about is the postcode in an address, don't validate the address format, because you don't want your code to break just because they decided they needed to separate address into 2 fields. If all you care about is the postcode, that's all you care about. The reverse of this is be very careful what you send, because you're making an implicit contract, and you have no idea who signed up on the other end of that contract. So we want to be very clear on what those boundaries are. Now, there are all kinds of ways to get around it. Dave talked about one earlier. But think carefully. What are you putting out on that wire? I'm from Thoughtworks. We have to talk about testing. But one of the things that we have found is if you think about how easy or difficult it is to test something, you end up with cleaner code. If you have a test, do this and then this and then this, of course, not that and then, you probably haven't drawn your box properly because you can't clearly express what that box is trying to do. So rethink that boundary. We've also found that things like business logic on the pipes are very hard to test. And so if you think about testability, it's going to steer you away from doing things that might make it difficult. So think about the testability of your system at every level. Unit testing, user journeys, overall systems tests, even performance tests. Think about testability. And of course, the dreaded people problem. We can't talk about architecture without talking about Conway's Law. One of the ways I appear very smart when I go in on some of our consulting engagements is I watch the tech leads as they walk past each other in the hall. And if they walk past like this, you got a problem. You got an integration problem between those 2 systems. I don't even have to look at the code. If those people don't talk to each other, the systems are not going to talk to each other. And so we need to pay attention to how our teams are behaving, how our teams are organized, what are the communication patterns, what are the communication dysfunctions. Because if you've got a dysfunctional communication flow in your organization, your systems are not going to work the way you want them to work. So we can't get away from the people problem. Okay, let's get a little more concrete. What are some things, what are some techniques that actually allow us to make an architecture more evolvable? And the first one I want to talk about is database refactoring. And I've been involved in agile software development for a long time. And first it was the QAs who said, well, I can't test a system until it's all built because, I'd have to redo things. And the business analysts, oh, well, I can't. I need to map out the entire thing before you can start coding. And all of these excuses. The people that I think had the best excuse were the DBAs. Because as soon as you got something into production and you wanted to change the database, you had to do a data migration. What's so hard about data migration? You copy it from one place to another. What could possibly go wrong? But it always does. This is a technique described in a book called Refactoring Databases with the subtitle Evolutionary Database Design that shows you for relational databases and conceptually for any category of data store how you can break down those large changes into small atomic changes that help you identify what part of the migration is where this is going wrong. Just like in continuous integration and refactoring, we're trying to isolate small changes, this is doing this for database changes. And this allows us to get things into production, to get feedback from our customers before we're completely sure we understand the whole problem. If you take nothing else away from this talk, database refactoring. Choreography. Now, this one is a little more controversial because I'm not saying orchestration should never be used. But if you think about it strictly from the perspective of how evolvable a system is, one that is choreographed is much more evolvable. Think about it. The conductor is standing in front of the orchestra, and the orchestra will not do anything unless that conductor is telling it what to do. And so there are all kinds of failures that just can't happen in an orchestrated system. Think about a ballet. You don't have the choreographer out there on the stage running around telling everybody what to do. They know what they're supposed to achieve. And if I am going to leap gracefully, and hopefully Dave will catch me, and if Dave falls down, well, I better not leap. But I know what I'm supposed to do after Dave would have caught me, and so I go and do that instead, because I know how to recover from these failures. But it's more difficult. So you want to think carefully, is the level of evolvability that I can achieve using choreography worth the additional cost? For many systems, it's absolutely worth it. For many organizations, it might be worth it, but they might not be confident of their ability to actually pull it off. So again, we have to think about the people aspect of this as well. But strictly from the perspective of evolvability, choreography is superior. Contract testing. This is a good way of allowing the maximum amount of independent work. I come up with a suite of tests that I give to Dave, and Dave gives me his test, and we're documenting the assumptions we're making about each other. And I do the same thing with James, and James does the same thing with Dave. And then we cheerfully ignore each other. I can make whatever change I want as long as I don't break those tests. And then I got to give James a call because I broke one of his tests. And so, okay, James, you and I have to have a conversation. I've got to make this kind of change. How can we work this out? We're still ignoring Dave. Dave doesn't have to get involved in this unless something that we want to change breaks our tests with Dave. And as soon as James and I come to an agreement, we go back to ignoring each other. That's how you get the maximum amount of work done, by making sure that you understand what are the commitments that you are making to the other groups. And then there's continuous delivery, and I will say this again. I believe that you need to have at least some of the rigors of continuous delivery in place before you try some of these more radical evolutionary architecture ideas, because you need to know the base deployments are working. You need to be able to isolate the changes that you're actually trying to make, confident in your ability to keep everything else the same. And this is the basis for experimentation. One of the reasons many organizations are risk averse is because they can't safely deploy their systems. And so they need to be really confident that this idea is going to work. Now the problem is, we don't know where the next great idea is going to come from. And what we'd like to be able to do is try lots of different things safely and follow the ideas that seem to be productive. But you need to have a platform for experimentation. You need to have a system that you can safely deploy, but also safely change. You can't experiment readily in a big ball of mud. You can't safely experiment if you're sitting there hoping, okay, please, 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 make the deployment be successful this time. You want to be able to celebrate the success of the experiment. Even if it didn't work, you learned, as was pointed out earlier. Which brings me to the culture of experimentation. Many organizations don't want to have to distinguish between a really good idea that just didn't pan out and a really bad idea. Not every idea is a good idea, but organizationally it's much easier to say, experiment success, yay. Experiment failed, bad. Even though you learn a whole lot more from an experiment that goes wrong because it tells you that you were assuming something that is not true, and you need to go find out what that is. I want to briefly touch on the evolvability of different kinds of architectures. And as I've said before, and Dave said it too, you cannot evolve a big ball of mud. On the other end of the spectrum is microservices. And some people have come up to me and said, you can't have an evolvable architecture unless it's microservices. Now, there's an argument that a microservices architecture is the most evolvable of the various choices, but it isn't the only one that displays evolvability, and you may, again, decide that you're not at the stage that you want to introduce the complexity of the microservices architecture until you understand more about your problem domain. Enter the well-structured monolith. You can do a lot of the same kind of evolvability. You don't have the independence of deployment and all of that. But in terms of the code changes you want to make, if you have a well-structured monolith, you can do a lot. If it's well-structured, it's easy to understand. It's got the right kind of considerations around coupling and cohesion. And if you've got good discipline, people won't succumb to that temptation to just reach over into that other part of the system because they can. A layered monolith gives you a particular kind of evolvability. If you want to swap out your persistence layer for something else, and you've got a layered monolith, that's going to be relatively easy to do. It depends on what kinds of changes you are most worried about. Notice I did not say which kinds of changes you think are coming, because you can't predict that. But you're going to know what worries you more. And if what worries you more is the change in business functionality, that argues against the layered monolith, because every piece of business functionality, almost by definition, touches every layer. And now you have to coordinate all of those different changes together. Some people think of a microkernel architecture as quite evolvable. I would argue that it's actually more adaptable, because you've explicitly decided these are the places you can plug things in. And maybe that's appropriate for your particular problem. But from our perspective of evolvability, when you don't really know how things are going to change, it's not as evolvable as it appears. Now, the dreaded G word, governance. One of the things, when we first started talking about evolutionary architecture, we were really more focused on the upfront, the design, the decisions, the architectural decision making. But what we realized is now that you have these fitness functions, you have an objective definition of what you want your system to do. And so if you want to see whether or not it matches all of your requirements, you run the fitness functions, and it'll tell you. And so governance becomes fitness function driven. We no longer have to have a code review for cyclomatic complexity because the build won't allow any code that has a cyclomatic complexity too great to get out. There's a whole category of questions we never have to think about anymore if we do our governance based on fitness functions. And we can allow the architects to spend their time on those more difficult trade-off decisions. Well, gee, the caching strategy that I was going to use to get the performance that I want, it conflicts with our staleness of data fitness function because of how I had to configure it. Can you help me? That's what you want your experienced architects dealing with, not you have a cyclomatic complexity of 31. That's not acceptable. The tougher transition, though, is to have those fitness functions be based on outcomes as opposed to implementations. So often, the dictates that come from the architecture group are use RabbitMQ in this particular way. I have spoken. Not what is the outcome you're trying to get out of using RabbitMQ in this particular way. And if you specify it on the basis of an outcome, then when some new queuing technology comes out that might be very appropriate for what you're trying to do, you can experiment and determine, do I get the outcomes that the architects have specified? But this is a very difficult shift for people to make. And in fact, we're guilty of it too. When we're trying to say, this is the implementation I want from maybe an internal platforms team, as opposed to, this is the behavior I would like to achieve. So we want these fitness functions and the attendant governance to spend more time on saying, am I achieving the outcomes, the behaviors, the characteristics of performance, of security, of operability, all of those different things, as opposed to, did I configure RabbitMQ correctly? Now, this is all fine and good if we're in a green field. We get together for our first project meeting and we prioritize our architectural characteristics and we put targets out there and then we start doing all of this and life is good. But many of us are not so lucky. We're left with big balls of mud and we're left with lots of systems that perhaps we don't even know what it does. The only documentation is the actual code. So what do we do? First, pick an architectural characteristic that you're most worried about. Not that you think is most susceptible to change. We can't predict that, remember. But what worries you the most? Check your defect log to see where most of the bugs come from when you try to add new functionality. My personal favorite, go talk to the operations team if they're a different team from yours and say, when do you guys get nervous when you hear we're changing something? Try to find the spots that are causing the most problems. Figure out what your target should be. You don't want to break the build on it yet. But start tracking it and start improving just on that dimension. Now, part of the importance of this, and this is why trends matter and continual monitoring matters. That's why you want to put these things in your builds as much as possible. Because let's say you've just convinced your VP of engineering or whatever the title is to give your team 3 months to clean this thing up. I can guarantee you, you won't have gotten out of that conversation without being asked the question, and how do I know you're not going to be back next year asking me for 3 months again? And you'll be able to tell them because you've got these fitness functions in place and you're monitoring these things, and it's never going to get that bad again on that particular dimension because you will know it. And yes, maybe you'll still make the decision, okay, because of a particular deadline or whatever, I'll introduce some technical debt, but you will be doing it intentionally as opposed to accidentally. And so you think about it for a little while, you pick out your dimension, you make some improvements, and then you pick another one, and you pick another one, and you expand your ability to demonstrate to the world, yes, my system has the architectural characteristics that we want. This is how we've defined success. Here's my proof that the system, in fact, exhibits those behaviors because all of the tests are green. And you continue this process. You go through and continually add a dimension. Now, part of the value in this is by focusing on not the things that are the worst, but the things that worry you the most. There might be that stinking pile over there, and nobody's touched it in 5 years. And there's probably a reason nobody's touched it in 5 years. Maybe it doesn't need to change. The purist in me, and I did used to be an academic, would like to say there should never be any bad code anywhere on the planet. The pragmatist in me says that's unrealistic, but let's try as much as possible to make the things that matter the most be of the highest quality. And so leave that stinking pile over there. Because maybe by the time you have to do something about it, you can actually get rid of it. So don't focus on what's most broken. Focus on the things that are broken that are costing you the most, that are keeping you up at night or making you go more slowly. If you hear your business strategy is going to focus on integrations or on mergers and acquisitions, I'd think about my integration architecture. But the important thing here is to think about how my desired characteristics might be changing as this ecosystem is changing. If you just come up with your fitness functions at the beginning of the project and never look at them again, they're no better, except they're executable, and so are probably at least being followed, than that binder that was imposed upon you from on high that nobody ever reads. So you want to reevaluate your fitness functions. Because what you are actually doing here is we're changing the definition of your target architecture. It used to be the target architecture talked about technology stacks and talked about component diagrams and all of those kinds of things. Your target architecture now is as much the composition of all those individual fitness functions. Not literal composition, but conceptual composition of all of those fitness functions. Because that tells you this is what the architecture is trying to achieve. These are the outcomes that I think are important. And, oh, by the way, here you go. All of them are green. Therefore, I'm achieving the architectural characteristics. And when something changes, whether it's a business requirement or a new technology enters, I can look at that and say, okay, what did that do to my target architecture? Can I just embrace it? Do I need to rethink some of my characteristics because something that was not possible before is now within the realm of the possible for my organization? So continue to evolve your fitness functions because the architecture is only as evolutionary as your fitness functions. Thank you very much.
All right, any questions?
I'm glad you're the one looking for hands.
Anyone? There. I might just squeeze past you if I might. Thank you.
Hi. So sometimes what happens with the architectural decisions is we are being pressurized with the business timelines where the business says, okay, something needs to be done quicker. And how do we bring that balance between the business timelines and the architectural decisions, which is correct architectural-wise?
As technologists, I believe it's our responsibility to help the business understand the consequences of their decisions. I had a situation, it was with a retailer in the UK, and one of their architects came to me and said, I cannot convince them to let me run the database recovery test. I said, what was your argument? And he went through this complex discussion of indices and what the database recovery test was going to do. I said, go back and ask him if he wants to know how long the database will be down if it goes down on Boxing Day. And the guy came back and said, that's all I had to say. We have to learn to describe in terms that connect with the value, with business value, the consequences of those decisions. Sometimes those business considerations should win. Sometimes the architectural considerations should win. We might think, well, of course, you always should believe me that this is the most important thing to do. But neither side should always win. But what we have to do is we have to put it in terms that make sense to them. The number of times I've heard people say, you know, we need to bring in this you know, integration, ubiquitous language, or you know, all kinds of things, nice shiny technology, and none of them can articulate why the business should care. So that's the first part. But sometimes they are going to say, sorry, business requirements trump. And we have to accept that. Now, if they never prioritize anything that you're trying to accomplish to position the system, then you need to start explaining to them, okay, next time I need to do something like this, it is going to take me twice as long because you didn't let me do this. Again, you're putting it in terms that they will understand as opposed to our language. And that's, to me, the single most important. Now, I will tell you, there are no silver bullets in here. If you've got a lousy boss who constantly makes bad decisions, there is nothing in here that's going to fix that. But at least this does provide you more objective measures that you can go and try to convince them this is why this is important to you, not just to me.
All right, that's about all we have time for, unfortunately. Please join me in thanking Dr. Rebecca Parsons.